So given a system of two masses, the location of the center of mass is given by this vector equation right here. And the way to interpret this is to say, hey, this is the position vector of the center of mass point is equal to this expression involving two position vectors for the two masses that comprise maybe the simplest imaginable system where you could ask what is the center of mass point. So what are we talking about there? Like we could be talking about like here's maybe some point mass. It has a mass m1, and then some distance away, maybe this one's larger, so I'm going to draw a little bit bigger, is a point mass with a mass m2. And what is the center of mass point? Well, it's going to be some point between these two. Hopefully that makes sense. But really, like I think what center of mass point tells you is kind of like the average location of all the mass in this system. So sometimes I've liked to say that this formula here on the key concepts page kind of reflects a weighted average in the sense that like, hey, like let's say that this one is located on a number line at a position of 1 centimeter, and this one is located at a position of 3 centimeters. If I just said what is the average position between those two, well, the average of 1 and 3, I think, is 2, right? Well, one way to get that is maybe to take 1 plus 3, which is 4, then divide by 2, which is 2, right? That's just a straight average. But let's say that for some reason this one had a mass of 1 gram, and maybe this one had a mass of, I'm trying to decide what might be a good number here. I'm going to make it 2 grams, right? That would make the average position, or kind of the average location in space where this mass is distributed, closer to this one, because there's more here than there is here. So I should weight the average by that amount. So instead of just adding 1 and 3 and dividing by 2, I'm going to take maybe 1 centimeter and then multiply it by 1 gram. And I'm doing this in this order because I'm trying to kind of parallel what this formula says right here. I'm kind of extemporizing this example here. And then I'd add to that the 3 centimeter position of the second mass, but I'd want to weight it by the 2 gram mass that it actually has. And if I were just doing a straight average, right, I would have just done 1 centimeter plus 3 centimeter divided by 2 because I added 2 things. In this case, I'm going to divide by the total mass that was there, which kind of, one way of thinking about this is like, well, there was 1 gram of these, 2 grams of these, so a total of 3 grams, right? And this is the way I would actually calculate the center of mass of this system. And I don't know, what is this going to... I kind of just made this up right now on the spot, so I'm not sure if it's going to... let's see, 2 times 3 is 6, but so this is like 7. Yeah, 7 over 3, I guess. Note that the grams all cancel, so that would be like 7/3 centimeters, right? And let's see, 7/3 is like... instead of 2, it's like 2.2 1/3, right? 2.33 or whatever centimeters. So instead of being halfway, it's like, well, you'd go like a third or whatever. So it might be like right around there or whatever is what I just showed. So that's the basics of how you do it. And in that sense, like, I mean, I've written this vector equation here, which can be intimidating, but in most cases, we can just remove those vectors and say, okay, the formula for the center of mass really is just this weighted average over positions. The one reason to maybe keep the vector notation is because to physicists and maybe other scientists and engineers, there's definitely a clue when you see a vector symbol that direction or position relative to the origin matters. In other words, if instead of having like two objects that maybe like, I mean, I didn't draw the number line here, but I kind of said like, hey, maybe this is at 1 centimeter on some number line. This is at 3 centimeters. That means there's an origin somewhere out here to the left, right? But what if I had given you a negative value for one of these positions? Well, these vector symbols tell you in one dimension, you would have to include that minus sign in the formula. So that's all this last thing really is about, is that in one dimension, you use signs to indicate sort of the direction in relation to the origin. Maybe I skipped over here the second point in the key concepts, which is like, well, what if it's more than 2? Well, you just keep adding more terms, kind of top and bottom, right? So you would, if you had 3 masses, you would add all 3 of those masses positions weighted by their mass, and then still divide by the sum of all three of those masses.